y'all for coming. Just one brief correction. I certainly worked on the Multics penetration test, but the report was actually by the late Paul Carger and Roger Schell, who were Air Force officers at the time. More of that history if you want to catch me at the end. But what I want to talk about today, as Alex said, was how we got to the commitment to secure development at Microsoft, and what the things are that made it work, and some of the things that we take away today. So to do that, I'm going to do a slide of sort of the prehistory that got people focused on software security, and how that bears, or how that bore on what Microsoft did. A lot of history of the SDL, including the origins of the Trustworthy computing email, some of the inside story that caused that to be released, and some of the relationships between that and some other things that made it work. And then after going through a lot of slides on SDL, I'll talk about some things that made a difference to making SDL adopted and effective in Microsoft and in the industry. And then I'm going to look back, because the SDL is actually 15 years old this summer, and what's changed, and what things are important today in secure development that are different from those early days. Hopefully do that in like 45-ish. That's an hour slot. Do that in like 45-ish minutes, and have lots of time for questions or push back. So in the 1990s, from a Microsoft perspective, the company was working. The company had Windows 3.1. About 3.1. It was sort of an overlay on DOS. No aspirations to security, and it achieved that very well. I think of Microsoft as we, although I didn't join the company until '99. We're also working on Windows NT. NT was a successor or evolution of VMS, intended as a sort of a modern state-of-the-art operating system, and taking some of the lessons learned from VMS, to the extent there were significant security aspirations, but those aspirations were sort of formed by the Orange Book again, by the DoD evaluation criteria, and focused on security features, which was what the evaluation community did back in the 90s, and still sort of does in 2019. Lessons learned started in the mid 90s. Sort of what I think of as commodity attacks on commodity software. The frack issue on smashing the stack for fun and profit came out in the mid 90s. That made people broadly aware of buffer overruns. Buffer overruns had been discovered before that, but the frack issue, I think, was really the thing that told everybody, hey, and you can do this too. There were lots of other mistakes in the 90s. The Internet Explorer was released. Internet Explorer chose the ActiveX extensibility model, and there was something called the Internet Exploder. You have to read the type carefully to see that. Internet Exploder was an ActiveX plugin that would download, run on your browser, and crash it. And so just to demonstrate that Microsoft had not gotten that aspect of things right. And lots of other things as well. There became an industry in finding vulnerabilities in Microsoft software, reporting them to Microsoft, or maybe in the early days just putting them out on the web, on some of the email, on some of the early email lists. I remember having to read Bug Track when I joined Microsoft as a way of tracking what was going on. In response, Microsoft created what they called the Security Response Team, started issuing security bulletins in response to newly discovered vulnerabilities, and then issuing patches to try to fix the bugs that were reported and verified. Internally, they also created something called the Security Task Force, which was an assembly of the people at Microsoft who understood or thought they understood something about software security, trying to figure out, what could we do about this sort of onslaught or maybe steady drip of vulnerability reports against Microsoft products. One of the outcomes of that, you can find it on the web. It was a paper entitled "The Threats to Our Products," which was a first cut at an approach to design analysis that they referred to as threat modeling. I'll talk more about threat modeling in the subsequent slides, but that was actually in early '99. And one of the other things that was done was to create something called the Secure Windows Initiative. And the Secure Windows Initiative was a team of 3 program managers in the Microsoft, the Windows Security Feature Team. And those 3 program managers, count them 1, 2, 3, were charged with finding the security bugs in Windows and filing bugs so that people would fix them. Okay, 3 program managers, maybe 40-ish million lines of code. You can do the math, but it was a kinder, gentler era. In 99 to 2001, I joined Microsoft in late '99 as the manager of the Security Response Team, which we relabeled the Security Response Center and added a batch of program managers to try to keep up with what was then an onslaught of bugs, and maybe also try to see what we could do to make things better. The Secure Windows Initiative team, I'll probably pronounce it as SWI as I go, changed its focus from finding the bugs themselves to training product component groups, all the different teams within Windows that were building various components. How do you look at your code? How do you find places where there might be vulnerabilities? How do you code so you don't have security vulnerabilities and fixing them? We had this thing called a bug bash where we'd spend the morning doing secure development and security testing training, and then the afternoon people would look at their components, trying to say, okay, these are the security bugs that we can find, and file bugs in the workflow system to actually get them fixed. There was some other work done as well. Talk a little more about that in the slide to come. In late 2000, there was something that I don't think is widely remembered, but at the time it was a big deal, and it was very much noticed internally. There was an intrusion into the Microsoft corporate network, this was sort of an early advanced persistent threat attack, and that got a lot of executive attention. How did this happen? What do we need to be doing to keep that sort of thing from happening again? what do we need to be doing to keep it from happening to our customers? And so, that was an initiative. Talk about that in a minute. In 2001, Code Red. I assume there are people in the room who remember Code Red. That attacked the IIS web server, IIS web servers on the internet, and if it did that by exploiting a vulnerability in a component that most people didn't need, but that was enabled by default. You'll hear more about enabling by default in a couple of slides. Code Red was followed in a couple of months later by NIMDA, which actually had 4 separate vectors of attack of different components of Windows. It also exploited a vulnerability in IIS and so crashed web servers on the internet. There was press about Code Red and NIMDA, and each of those press reports attributed like $8 billion worth of aggregate customer cost to cleaning up the damage from Code Red and NIMDA. And then later in 2001 was really sort of a banner year. We had released in Windows XP in August, and later in the year there was what was called the UPnP vulnerability in XP, which I'm not convinced was ever actually exploited, but there was one vector that made the government afraid that we were going to start taking government sites off the network or launching DDoS attacks against the government. And so a lot of news, a lot of press, a lot of concern. And the Seattle Post-Intelligencer was then the local paper, and people became aware, gee, this is something that customers are concerned about. The story as well was that along about that time we got to the point where customers were calling Microsoft executives, and then instead of talking to them about business or new opportunities or new sales, they were yelling at them about their bad security. And my friend John Pescatore from Gartner issued a report that said, hey, maybe if you're using IIS for your web serving on the internet, you ought to stop. And so that was another attention getter. After the CorpNet attack, we'll go back and forth a little, Howard Schmidt, who was then the chief security officer at Microsoft, and Craig Mundy, who was one of the chief technology officers, started to meet and work together. Howard came to work for Craig, and they started to say, okay, what could we really do to get ahead of this, to change this dynamic, to get the company both more secure and perceived as more secure by customers. And that led to the sort of thing that you see at big companies, a lot of meetings, a lot of emails, a lot of briefings, a lot of demonstrations, including demonstrations for the most senior management of the company. And that ran through 2001 and into early 2002. In parallel with that, Michael Howard and David LeBlanc wrote the Writing Secure Code book, which came out in late 2001, and said, okay, these are the things that we know about building secure software in C and C++. Talked about design as well as code level, variety of techniques. If you followed what's in Writing Secure Code religiously, you'd be building a lot better code than in the late 90s Microsoft was. And then in early 2002, the payoff from the Howard and Craig initiative was the Trustworthy Computing email. And that was an email to all employees and made public from Bill Gates that said, hey, this is a serious matter. We have to commit to security. We have to prioritize security over features. We have to do things in a different way to protect our customers' security, privacy, and other attributes of trustworthiness. And that came out, and in response, my friend Pescatore, who was a little bit of a skeptic back in those days, issued a report. I couldn't find the exact wording, but the approximation is Microsoft has this terrible product security problem, and in response to that problem, they've issued a press release. So commitment but skepticism. In parallel with the run that led up to the Trustworthy Computing email, those of us in Windows security, sort of closer to the trenches, were worrying about, what could we do? I had changed jobs in mid-2001, and in addition to the Security Response Center, I moved into the Windows security team and also inherited responsibility for the Secure Windows Initiative team. And we had an offsite meeting, what are we going to do? What's our budget? What are our hiring plans? What are our deliverables? And what are we going to do about this big problem that's running? And we had this offsite meeting sort of late October of 01 at a time when the .NET Common Language Runtime team was about to ship their version 1. And they knew that security was important. They wanted to compete with Java. They wanted to be a major force in the managed code space. And they kept finding security bugs. And they said, how are we going to get ahead of this so that we don't just have this drip of security bugs coming at us when we ship? And they decided what we're going to do is delay shipping, stop work on features, and focus everybody on doing security reviews and security testing. And they did that, and the process was going on. Michael and David LeBlanc were involved in it. They were both at this offsite meeting, and they said, they talked about what was happening and how it was going. And they said, that's an approach. And I said, well, what would happen if we did that on the next Windows release? And the consensus of the meeting was that, A, that was a big lift. Windows was like 8,500 developers, and B, nobody had any better ideas. So I went to my boss and I said, let's just stop development on Windows and focus everybody on security. And my boss said, how would you get people to do that? They'd just roll their eyes when we briefed them and then go back to doing business as usual. You wouldn't be able to get it to work. But he said, he didn't say stop. He said, come back and answer some list of questions. So I came back to him and said, okay, this is how we do it. This is, how we'd organize it. These are the resources we need, and so on. And he didn't say yes, but he didn't say no. And the next meeting was with the vice president who ran Windows Server, and sort of rinse and repeat. We kept going up the management chain with nobody saying yes, but nobody telling me to go away and never come back. And finally, we met with Jim Olchin, the group vice president, who basically owned many of the software products, everything but Office. And Jim's question was, okay, when do you want me to preempt the conference center so we can train everybody? And we said, how about the end of the last week in January? And so the last week in January, we preempted the conference center. There was a room that held 900 people there, and we did 10 training sessions, morning and afternoon, over 5 days, and trained about 8,500 developers. And here's a trick, okay? People who are in big organizations know about mandatory trainings. You show up, the vice president walks in, or if it's an academic institution, the dean walks in, he tells you why this is really important, and then he walks out, or she walks out, and the training starts. Well, in this case, the vice presidents for the various component groups in Windows showed up, gave the introduction, told people why this was important, and then sat down and sat through the 4 hours of training. And that's a message to the culture. And there are things like that that worked for us through the security push and actually through the rollout of SDL that sent the organization the message that we were serious about this and we actually wanted to build more secure software. So we did the security push. We got a commitment for 1 month. We extended it to 2 months. There's a list of things that we did on the slide. We actually inventoried all the components in Windows and said, okay, who has to sign off on each one? We did our then version of threat modeling. I'll come back to that yet one more time. Well, the preview is that the guy who later became my boss was so mad at the quality of our threat modeling guidance that he yelled at me in the hall, which was not his style. We had some static analysis capability. We had bought a company called Intrusion, and we started running that and auto-filing bugs where we thought they would help us find buffer overrun vulnerabilities. We told people, that remember about Code Red and NIMDA exploiting vulnerabilities and features that people didn't know they had and weren't using. We told people, if you've got stuff like that, turn it off. Discoverability means that your system is owned by exploitation of a vulnerability in a feature you didn't need. And so we said, turn it off and give people a way to turn it back on. And we also took a perspective that we didn't want people trying to decide whether something was exploitable or not. If it meets these criteria, fix it, okay? And that created a lot of code churn, but it also enabled us to find a batch of vulnerabilities and get them get them fixed. We ran the process through the Windows development process, through the Windows development process, through the Windows development team. Windows is sort of a machine. They have a cadence of daily meetings, reviews, bug triage, what have you, and we just said, all right, building secure code is part of building Windows, and so we did the security push as part of the Windows development process. And I think that was sort of key to our actually getting it done at scale. I said we stopped for 2 months. We probably delayed Windows by 6 months by the time all was said and done. And that more or less worked. We shipped Windows Server 2003 in the spring of 2003. It looked like a much more secure release than its predecessors, and we sort of had turned things around to a significant extent. In the Secure Windows Initiative team, we ramped up to a significant team, couple of dozen, 3 dozen people, with the capabilities shown on the slide. Security science was our name for finding new classes of vulnerabilities and being able to find ways of fixing them. And in a couple of cases, we were actually able to do that, find a vulnerability, build a tool, scan for all the instances of that, and eliminate it before the vulnerability researchers ever got the MSRC in business to fix it externally. So that was counted as success. It's something that still goes on. We replicated the Windows security push for other products. We released a service pack from the security push on SQL Server the week of Slammer. And that was always something I found sad, because that was a huge worm that affected the previous version of Slammer. And once we released that service pack, security push service pack, the vulnerability rate in SQL just dropped like a stone. So that was sort of a sad event, but probably a happier outcome in the long run. Blaster caused us to focus on XP, the client desktop. We did more on Windows XP, and probably set back the Windows schedule by another year, taking the time to go back and do some set of security changes to XP. Not as many as we would have if it had been a full release, but more than we had initially had the appetite for. In the winter and spring of '04, had a batch of conversations. You know, we're not there yet. We need to do more. We need to do this on a sustainable basis. You know, could we do something that would be mandatory? We put together a proposal, briefed Ballmer and his staff. Ballmer turned to me and said, "That's approved." He turned to his staff and said, "Okay, we're not ever going to talk about this again. It's done." And that was the commitment to enable us to put a mandatory set of security measures into development for all time. And in July of '04, we released SDL version 2, which was a training requirement, basically the same technical stuff we did in the security push, and a final security review, which I'll talk about in a couple of slides. And this is just the picture from a little later in the history of SDL. It sort of gives you a feel for what we did in the SDL. We were very, you know, this is still a list of sort of generic things, but we were very specific. I mean, we said, you know, what you had to fuzz and how many 100,000 iterations you had to fuzz without finding a vulnerability. We said what specific static analysis errors you had to fix. So very specific and mandatory for products that connected to the internet. And the SWI team supported the process, but the secure development was done by the development groups. You'll hear me repeat that over and over because it's important. We had like, you know, by the time, you know, after multiple reorganizations and a lot of growth, you know, the SDL team at Microsoft was about 60 people. Sounds like a lot. The developer population that we were responsible for was about 40,000. You know, so the only way to do that is with tools and training. Verification, we said it was mandatory. What we meant by that was that you had to meet the requirements in the SDL. If we said fix static analysis error 1, 2, 3, 4, and you had static analysis error 1, 2, 3, 4, that was a ship stopper or an escalation. And we also said you can't ship with known vulnerabilities. There was sometimes a penetration testing component. Obviously, you wouldn't ship with public vulnerabilities, but in the main, what we wanted people to do was do the SDL. At one point, one of the product groups came to us and said, "Hey, we've just heard early on, we've just discovered this thing called the SDL. We haven't done anything about it. What can you do for us?" And we said, "We can tell you not to ship." And so they went back and fixed it. There are other stories about things. Early on, it was pretty raw. I told you about the guy who became my boss yelling at me about threat modeling. Threat modeling for a long time was great if you were a security expert, and otherwise too hard, too ill-structured. Some of the tools were unusable. Some of them were less than productive. The services team, you know, the online services, MSN, Hotmail, you know, they were releasing updates every day, every week. You know, you saw that slide with the picture on it that looks like a 3-year waterfall cycle. You know, how are we going to do this? And so there was a lot of feedback and a lot of work to do. But we had said that we were going to, you know, that the SDL wasn't a finished thing. It was something that was going to iterate, and that was part of the approval we got. And so we were updating every 6 to 12 months based on product group feedback and advice, and telling us that stuff wasn't usable or wasn't needed or was needed. The other big thing is the MSRC cases. We didn't say all the vulnerabilities are going to go away. What we said is that as we find them, as people report new vulnerabilities or new classes of vulnerabilities, we're going to figure out where they came from and try to add to the SDL things that will enable us to extinguish those, either by removing them or you know, the next bullet has the word mitigations. What we meant by mitigation was if the vulnerability is still there, but you can include a control that will make it non-exploitable or make it hard to exploit or make it a crasher instead of an escalation of privilege, you know, that's still something that we're happy to do. And so things like address-based randomization, non-executable stack and keep, eventually control flow integrity, were things that we mandated as part of the SDL to make it harder to exploit vulnerabilities if they were still there. And scale. You know, I talked to you about Ballmer saying that there were 40,000 developers. We realized that. We started out doing, you know, individual training in a room, switched fairly quickly to online. We started out with a lot of manual requirements. We knew we were going to have to build tools. And an interesting thing that we initially didn't realize we were going to have to do. When we started, we were tracking product teams' implementation of the SDL on a program manager's whiteboard and in spreadsheets and scraps of paper. And we fairly quickly discovered that we were going to need an automated system you know, to let people understand what requirements applied to what they were building and to tell us whether they had done the SDL. And part of the trick there was making that seamless. I've got a little more about that in another slide. So let's see that. So back to the product team complaints. They said threat modeling was too hard. A fellow named Sean Hernan, who was one of our program managers, came up with a new, much more structured way to do threat modeling. We built a tool that implemented that. It's a free download from the Microsoft site if you're interested. And we never mandated. If people were security experts and they wanted to do a different way, that was fine. But we built that tool and used it for many of the new products. And it was much more effective. And you didn't have to be a super security expert to do threat modeling and get results. We fixed the tools, obviously, for usability where we could. Sometimes if there was a tool that was bad, but the alternative was shipping with vulnerabilities that we didn't know any other way to find, we said, suck it up and use that tool, because it's still better than patching them one by one. We deprecated tools that didn't work. We adapted the process to fit into an agile or DevOps lifecycle and published that. So lessons learned, it worked. I'm long gone from Microsoft. Things have changed a lot, but the SDL still lives. The reason it worked, the reason it lives, is because developers want to do the right thing. When you publish something about Microsoft security sucks on the front page of the Seattle Post Intelligencer, that gets people's attention. When Bill Gates says we need to do this to continue to thrive as a company, that gets people's attention. And the developers want to do the right thing, and that's key. You can't compliance security into big products. You have to build it in as part of building. And so, that's a huge lesson learned. People tell me, if they have some other model of doing security, people tell me that the SDL is penetrate and patch. No. The SDL is continuous improvement. Find a problem, find the root cause, and eliminate it for all time. And that's got to be the secret to building secure software. Talked about that, got ahead of myself. Automated tools important, integrating into the development workflow. I talked about tracking systems. We eventually got the SDL requirements, so they just populated into the developers' bug tracking systems. You fix the bug, it's a flagged bug, so the SDL team can go look and see, did you do everything you're supposed to? But it's just part of the workflow, and that's a key to success with a secure development process. It's just part of the workflow. It's just part of what the developers do. They get a bug, they fix the bug. It was a security bug, and they've met the SDL requirements, and that's super important. I claim it's worked. Part of the reason I think that, these are very, these are sort of fluffy metrics, but they're real. Customers talk to Microsoft executives about features or prices or orders or what they want next. We're not in the days of yelling at executives about our bad security anymore. And that was a huge change. Industry, there are companies, some of them I think probably represented in this room, have adopted the SDL or adapted or emulated it. Some of them have acknowledged that, some of them haven't. We don't care, we released it publicly. Didn't care, we released it publicly. And the important thing was to make the industry more secure. Final, how do I know it worked? Track the price of a Windows O day. I actually heard that from a very well-known vulnerability researcher. It didn't occur to me that was the metric for how a secure development process had worked. So, a couple of more slides. What's changed in 15 years? When we built the SDL, we worried about C, C++, and C#. I was talking with some folks at Microsoft a week ago, and I said, you must be worrying about 10 or 15 languages now. And they said, something like, I wish it were that small a number. It's part of what it is, but the fundamentals are still the same. For every language that you're using, you got to figure out how to assure security for code in that language, and then you've got to provide guidance, tooling, process, testing as appropriate to make it work at that scale. Speed, I talked about the online service people and adapting. How do you do it? How do you do it for Agile or DevOps? Well, the key thing is to integrate into the developer workflow. If you can do that, you win, or you win enough. And supply chain. That's sort of governmentese for using somebody else's code. When we started, we mostly wrote everything we shipped. Today, everybody does third-party code, especially but not exclusively open source. And so, you have to have a standard for acceptance of what open source you'll use. You have to have, maybe you have to have an initial quality assessment or review to make sure you're not going to do something to yourself when you adopt some code. if you're relying on a third party, you got to know what that is. You've got to know who's responsible for it, whether it's you or the third party, and you've got to be prepared to respond when vulnerabilities are discovered. And ideally, you've got to be able to continuously improve it or know that somebody else will continuously improve it. So, summary, it works because the developers are writing the secure software. We're not compliancing security in. I told you, 60 in the SDL team, 40,000 developers. You can't test after the fact and get to security at that kind of a developer population. Just think about it. How many people would it take reviewing the work of 40,000 developers? So, you get the developers to write secure software. And the product teams have to buy in to do that. And part of that, is understanding what bad could happen. Part of that is watching other people's stories. For us, Code Red and NIMDA weren't fun, but they were instrumental in making the changes we made. And the security team becomes advisors, facilitators, experts, not inspectors or testers, and it's small compared to the population. So that's, sort of 20 years or 30 years of history in about 45 minutes, which was pretty much my target. People have questions or pushback or feedback. I'm here until Alex pulls the trap door.
Questions? So if you have a question, please come up to the mic. If you would like to give a talk, please submit to the CFP, though.
Thanks, that was a great talk. I'm curious, one of the things you mentioned was, well, I have many questions, but there's no one behind me, so I can...
Nobody behind you, go for it.
So one, the people write secure software out of pride. A lot of software is developed by outsourcing or contractors to come in, hack something and build. Does the pride for company, does the pride for the product, because you're going to do something new next month, still be there? And then how do you secure in that context? And the other thing is you mentioned supply chain, but another thing that's happening right now a lot is cloud software, Salesforce, marketing campaigns and all that. And a lot of the users are not developers, but there is still a lot of technical configuration, and a lot of breaches nowadays happen due to configuration errors and keeping S3 buckets open. Who would do that? But people do. And so in that context, how do you think advice for people configuring these complex systems could apply? Some lessons from here.
Okay. So two questions. One of them is contractors, transient employees, what have you. Our experience, was that we used relatively few contract employees. We had various kinds of folks on staff, but in general, people were long-lived in the environment, and they were expected, to follow the rules, to do the SDL. That was part of what was in the development environment. That was part of what they were hired to do. If you contracted with somebody for a deliverable, a thing that we did some of was to basically include SDL terms in the contract. That puts a stress on being able to select a contractor that you trust to do that, but that's part of the requirement set. The second question, about cloud services and configuration. So two things. One, your cloud service provider ought to be doing secure development, and you ought to, figure out whether they are or not. If they're not, maybe find another cloud service provider. And then the other thing, in terms of configuration and locking down, the SDL lessons apply as well to operations. And we actually built a companion process called OSA, Operations Security Assurance. But the basics are, what are the requirements? how can you build, how can you build tooling to confirm that those requirements have met? How can you do continuous improvement to make sure that things are being updated as needed based on new threats and new incidents? But the lessons are still there, although I mean, it's a little different because you're not sort of doing a build and release. It's sort of continuous, but maybe you're doing continuous scanning to ensure that the things you expect your configuration to be still are that. So so that was something, and we actually had pretty good luck with the OSA experience.
Just one quick, did you sue anyone for not following the SDL when you had it in the terms?
Say it again?
Did someone, you said you put it in the legal terms that you must follow SDL, and did you ever sue and get back the money, or
No, I mean, you mean for third party, for third party or contract code?
Yeah, not following SDL.
No, I mean you basically provide feedback and say, really do it.
I think there was like a Simpsons episode where Microsoft lawyers come to provide feedback to
Hi, Dave Wagner from Berkeley. Great talk, thank you. So I'm wondering about how you would suggest we think about a situation where you ship product 1.0, version 1.0 of the product that was built to the SDL at the time, and then you discover a new threat and the SDL gets updated with some new coding rule, and now it's time to build 1.1 or 2.0 of the product. So you got some existing code and then you're writing some new code, and you could imagine saying, oh, go back and sweep through all the existing code to now comply with the new coding rule to deal with that threat, which would maybe be the safer thing, but on the other hand puts a lot of friction in sort of upgrades. And so just wondering if you had any experience about how to think about dealing with that trade-off.
So one of the things, so if you look at, I think SDL something like 5.2 is downloadable on the web, and I think it probably includes language that distinguishes between new code and all code, okay? And all code, when it says all code, you run on everything and fix it. So we did in fact understand that, acknowledge it in terms of how we decided between all and new. That was basically a risk-based judgment. And if you look on the web, there's actually something called the SDL bug bar that gives you at least a sketch of how we thought about the severity of the problems that we were dealing with or responding to. So so those were things that we did think about. We understand. I mean, it's always a balancing act. The reason I didn't get this into the talk. Part of the reason we didn't include XP in the original security push, the 2002 security push, because it was out there, and so the product executive said, if we make this level of change to a shipping product in a service pack, customers won't install the service pack, and so that there were other things too, like we had a deadline for antitrust, but those are the sort of considerations that you're balancing.
Thank you.
Thank you.
Hey Steve, great talk. This is Swapnil from Amazon. So with new concepts coming like lean startup and fail fast, developers usually want to ship features fast, and they promise to either public or leadership we want to do this, and if their promises conflict with SDL, or if that SDL timeline increases whatever they plan to deliver on, how do you deal with the trade-off there? Yeah, we want to deliver this, and if we do this, it will consume more time.
So the key thing, the key thing, that I think worked for us was being able to integrate the tooling into the developer workflow. Okay, that was super important in actually, being able to meet the needs of Bing, MSN, Hotmail, and it's a continues to be an important consideration. If you, I mean, I remember talking to a company that was trying to do an SDL, and their model had become, build the software, run the static analysis at the end, give the static analysis bugs back to the, to the developers, and then tell them to fix them. And this was, the company in question actually using a static analysis tool where you could run it on the desktop. And so I told them, run it on the desktop, give the developers the feedback immediately, and just, when they build code, it's secure code or closer. But you have to have that mindset of integrating security into the development. And that, I don't guarantee that will solve every problem, but it will go a long way toward getting you shipping secure code rather than shipping security patches.
Thank you.
Hey, thanks for the great talk. I'm
Thank
Michael Samler from the MPI for Software Systems. And yeah, I know that Microsoft is also involved with projects like FStar and which do more verification. I would be interested in general, what are your thoughts on formal methods and formal verification of code to ensure security?
Back to Alex's introduction. I mean, one of the things I did in my misspent youth was to lead a project building an A1 system under the Orange Book. And so I'm sure that my experience with formal verification is not up to the standards of today. If you can do that and you can get it integrated into the developer environment, I love it. Our experience back in the A1 system days, was very much like the model I said we don't use for SDL. We had the verifiers as a separate team. They were doing they were doing specs. They were doing formal verification. We had these big meetings to map the code and the designs to the formal versions of the code and designs. And so, that, especially today, the previous question about, rapid development, rapid deployment. I mean, you've got to make that trade-off. I'm a believer in formal methods. I read the Hackham's papers, and I think that's really cool stuff. But it's got to be consumable by the developers who are doing the scope of the product you're developing, and it's got to be possible to ship in time. And so, I'd say aspirational.
So do you know any technologies which are already usable by normal developers, or does Microsoft use some things there, or is it more
the main, the two mainstream payoffs? I'm not sure whether this is a cheat or a non-answer or not. The two mainstream payoffs, there's a lot of formal methods that have made their way into the static analysis and fuzzing. And Microsoft makes huge use of both of those. And then the other thing is to the extent that you can get to managed code. I'm not sure I don't think that's really a formal methods answer. But getting to managed code and getting away from the memory errors is super important if you can do it. Thank you.
All right.
Okay.
No more questions?
No more questions?
Okay. Let's thank Steve one more time.
Thank you all.